There is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
As a species, we've been looking up at the sky for a very long time, but not very long in the grand scheme of things, at least as far as life here on Earth is concerned. For as long as we've been looking, we've also wondered about the things that we see. The moon, for example. Before we could explain what it was, we anthropomorphized it. We did the same with the sun. When a solar eclipse occurred, it truly defied logic. But then, as a species, we began to understand the world. With telescopes, we could see the moon a lot better, and beyond it, the stars. We stood amazed when we were able to view what we thought to be artificial canals on Mars. And this led us to contemplate what life was like on the red planet, so far away from us. Would they, the Martians, in the years that followed, turn out to be a friend or a foe?
Scouting planes report 3 Martian machines visible above treetops, moving north toward Somerville with population fleeing ahead of them. The heat ray is not in use, although advancing at express train speed. Invaders pick their way carefully. They seem to be making a conscious effort to avoid destruction of cities and countryside.
Now, that was an excerpt from Orson Welles' 1938 broadcast of The War of the Worlds, which was adapted from the 1897 novel of the same name by author and visionary H.G. Wells. Needless to say, the seed had been planted. Does life exist elsewhere in the universe? And what about our solar system? Or even Venus, perhaps? Or are we alone? Completely alone. The sound you just heard is plasma waves between Saturn and one of its moons as captured by the Cassini spacecraft. And what else was it doing besides studying radio waves between Saturn and its moon? It was helping us learn more about Saturn's atmosphere, among many other things. And armed with that knowledge, it'll help us to better understand other planets, planets that might harbor life. And how do we do this? How do we find life in a galaxy or galaxies far, far away while sitting here on Earth? It's not just by looking through telescopes or sending probes. Those will tell us a few things, but not everything. We need a multi-disciplinary approach, one that combines astronomy, biology, oceanography, and chemistry, and the list goes on, and that's just to name a few. But if you roll them all up, enter astrobiology. As a discipline, astrobiology hasn't been around for very long, a few decades. It was once known as exobiology, a term created by John Lederberg, a molecular biologist who discovered that bacteria can mate and exchange genes. But that's not to say exobiology and astrobiology are interchangeable. So to explain that, I'll let astrophysicist David Morrison take over.
Exobiology, while the word goes back quite a long way, had really come into its own in NASA at the time of the Viking missions to Mars. And it is focused on the understanding of and search for life beyond the Earth. Astrobiology attempts to be a little broader. We are going to include the Earth. We are going to study life in the universe wherever it is. And in practical terms, the only life we've discovered yet is on Earth. So most astrobiology is concerned with understanding life on our planet, its origin and evolution, and the habitability of strange and extreme locales on our planet.
So now that we know the difference, what we are here to look at today is astrobiology. So now that we have the term and the discipline defined, what do we do with it? How do we find life without hopping onto a spaceship and traveling to those distant galaxies? Well, we look through our telescopes and our spectrometers. We study the gases and the chemicals present in a planet's atmosphere for, say, biosignatures. We measure a planet's distance from the sun it orbits, looking for those planets that fall into what is called the habitable zone, or the Goldilocks zone. In that zone, we hope to find planets somewhat similar to ours in that water could be possibly present. Where there's water, so too might there be life. Now, there was close to 2,000 confirmed planets outside of our solar system, with the possibility of millions, if not billions more, but we simply can't see them all. According to a recent article in National Geographic, we have identified 16 in the Goldilocks zone of the suns that they orbit. That's 16. So depending how you look at it, that's either a lot or it's very little. Now, there are some assumptions we have to make about these planets being capable of harboring life. I've already mentioned one of those assumptions, the presence of water. Now, that's because water provides an environment for the formation of complex carbon-based molecules. The thought is that since all life on Earth has carbon at its base, then so too might life on other planets. And for that you want water, as well as energy from the sun that the planet orbits around. But there's a problem here. And it's not a big problem, but it's a problem nonetheless. We have only one planet to base these assumptions on. Only one planet in the known universe that we know has life on it. Our own. We might be able to throw some of these assumptions out the window. Life might not require the comforts that we enjoy. And by comforts, I mean the type of environments, climates, and access to the sun's energy that we have here on Earth. The thing is, biologists have found organisms that thrive without access to sunlight and in extremely harsh environments. They call these organisms extremophiles. And some of these happy little creatures live in ice, acid, boiling water, and even toxic waste. Now, we wouldn't last a second in such environments, nor would we think life could live and evolve there, yet it does. So that being the case, maybe the planets conducive to life out there is much greater than we thought. Life might originate in all sorts of environments. So the astrobiologist has a lot of theorizing and searching to do. So perhaps there are many planets out there teeming with life. Life may have originated many different times and in many different ways. It also may have formed in one place and been transported to another, as the hypothesis of panspermia suggests. Meteors and asteroids could even be the means of transport. In 1969, a meteorite hit the ground near Murchison, Australia. It is now known as the Murchison meteorite, and it's an amazing glimpse into the past. And why? Because it's 7 billion years old. That's 2.5 billion years older than our solar system. And it's special in another way, for what it actually contains. Studies have revealed that it contains 74 different amino acids. Darwin theorized that life sprung out of a warm little pond. It could be that a meteor hit that little pond for it all to have happened. That may have occurred many times on many different planets. How life evolved from those other warm little ponds, we simply don't know. The problem being that we still have only one instance of life to fall back on, one tree of life to study. Now, if we had other trees, other examples of the origin and life and its evolution, it could open up many more possibilities. But first, we have to find those other trees. Or life.
The other thing we can do at the other end of the observational spectrum is we can say that if life had arisen on any of these other planetary systems and evolution had gone through a kind of sequence of stages analogous to what it did do here, some fraction of these planets with life may have given rise to intelligent beings capable of producing technologies. And we might be able to observe the technologies. And in particular, we might be able to observe artificial radio transmissions or artificial laser beams or artificial signals of some kind.
That was Professor Andrew Crawford from Birkbeck University of London, from a talk he gave at the Royal Institution. Now, for there to be life, it first has to evolve. It has to have some semblance of a metabolism, and it also has to replicate. From there, it can follow many different directions. It doesn't have to be in the same direction that we see around us here on Earth. The tree of life on a distant exoplanet might be completely different. It most likely will be completely different. The amazing thing is, the notion that life evolved elsewhere wasn't only the stuff of fiction in the past. Over 100 years ago, Alfred Russel Wallace, who had independently come up with a theory of evolution by natural selection at the same time that Darwin did, wrote a little book that could be considered the first book ever on astrobiology. That was 100 years ago. The title of the book is Man's Place in the Universe. Published in 1904, it examines the possibility that life may have evolved elsewhere. In it, Wallace writes about spectroscopes, spectrum analysis, the study of gases on heavenly bodies, and telescopes with micrometers. In it, he writes, and this is a quote, "Before trying to comprehend the physical conditions on any planet, which are essential for the development and maintenance of a varied and complex system of organic life comparable to that of our Earth, we must obtain some knowledge of what life is, and of the fundamental nature and properties of the living organism." Wallace then attempts to define what life is, and that definition includes replication and constant change. And in order for life to occur, it needs, and this is taken directly from Wallace's book, solar light and heat, water in great abundance, and an atmosphere of sufficient density and consisting of the gases which are essential for vegetable and animal life. Pretty heady stuff, huh? Wallace also discusses the possibility of life elsewhere in our solar system and whether our neighboring planets are capable of sustaining it. He immediately excludes Mars and Mercury as being too small and not having the right mass to retain water vapor. Not too bad. He lands on Venus, though, as being the only other planet capable of sustaining life. Now, it's worth noting that phosphine has been detected in the atmosphere of Venus, and its presence suggests that living organisms may be present to produce it. It's a controversial discovery and one which the debates and the dust haven't settled on yet. Now, in his book, Wallace ultimately comes to the conclusion that life formed here on Earth and here only. He can't help but wonder, though, what it might have led to were it to have happened elsewhere. Now imagine if he were given access to the work of astrobiologists today. I have no doubt that Wallace would have appended his book with a slightly different conclusion. I hope you enjoyed today's episode of Evolution Talk. I'm Rick Coast, and you can find show notes and source material used for this episode at evolutiontalk.com. Now, I hope your week is going well, and until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.